So yeah, hi guys, welcome to the final session based on your chapter 7, triangles and its properties. Today we are going to do certain sums which have been asked in your previous exams related to this chapter, or some important questions that you should know. They can be asked anytime, anywhere in your examination. Just that depends on your teacher. So we will be discussing some hotly asked questions related to this chapter. We will be revising certain questions from NCERT also that are important and you should have a grab over them, and we will be having a revision point also where you will be revising each and everything that you have understood regarding the triangles and their properties. So I will be having each and everything in this video, but remember this is a practice video in which we will be having sums to practice on. So you guys have to practice each and every sum with me. You have to try that sum with me. And remember, this chapter should be carried on with the chapter 8 and followed up with chapter 9. So you must not skip this chapter. You must not skip the chapter before this one. That means the lines and angles. All these four chapters are related and you must not skip them. I am repeating, you cannot skip them. They are very important, very easy also. So we are going to start with the chapter, the practice video now. And before, let me get to the point right here. If you want to practice furthermore, if you want to have various sums to practice on, a lot of question banks, the questions that are present, they are already available on our website. We have recorded sessions there too. We have various practice questions too. We have revision notes there as well. So if you want to practice a bit further than the video, that means the sums that we are going to have today, see, we cannot have more than 20 to 30 sums at a given time. So remember, if you want to practice more, if you are not satisfied with the number of questions that we are going to have today, you can always log on to our website, or you can just download our application which is available on Play Store and App Store. You can just download that application. You can just get yourself registered. There you can ask me doubts, you can have your problems, your queries resolved there. You can have doubt sessions with me. You can have a lot of things. You can do various things there. You will be having fun there. We will be having various test series there also. So remember, we have revision notes, we have practice questions, PYQs, previous year questions. So we have a lot of things on our website. We have recorded sessions too. So why are you waiting? What are you waiting for? So log into our website, download our application, get yourself registered. So that being said, let us start with the video. So before we get to the point, let's revise each and everything that we have learned up till now. So you guys see, we had understood what a triangle was. So any three-sided figure such that three of its vertices were not lying on the same side, that means there were three distinct vertices and none of those three were collinear, that figure will be what? That figure will be a triangle. You had what? You had the types of triangles. So there were some basic properties of the triangles. There were three vertices, three sides, and three angles. Then we had understood about the types of triangles. You guys see, we had equilateral, in which all of the sides were equal, right? Three sides were equal. Each angle was 60 degrees, right? So we had that also. Each angle was 60 degrees, and that was the case, right? Then we had the case of isosceles, in which we had what? Two adjacent sides equal, and two base angles equal, or you can say angles opposite to equal sides were equal. That was the case of isosceles. Then we had scalene. In that we had what? None of the sides were equal. No sides nor angles were equal. All the angles were different, and all the three sides were of different dimensions. So these were the types of triangles on the basis of the sides and angles. Then we had one more type, which was your right angle triangle, right? We had right angled triangle, which was what? It was a triangle in which you had one of the angle exactly of 90 degrees and other two less than 90, or their sum together was equal to 90, and you had understood that one of its side was perpendicular, another was base, and third one was hypotenuse, right? We had understood each and everything. Then we had acute angle triangle. What was acute angle triangle? In which a triangle in which each of the angle was less than 90 degrees. Then we had obtuse angle triangle. So what were obtuse angle triangle? It was that triangle in which one of the angles was more than 90 but less than 180. It was more than 90 but less than 180. X greater than 90, less than 180. So in such scenarios, you would be having an obtuse angle triangle. But remember, in acute angle triangle, there can be three acute angles. In triangle, all of the three angles will be less than 90. But for the case of obtuse, only one angle will be more than 90 but less than 180, because angles and property states that sum of all three angles of triangle is exactly. That was the main thing. We had learned everything. Then we had got to the point of congruency. So you guys remember what was congruency? Congruency was that property by which you should place two objects on one another such that they were sharing same size and same shape. Or for the case of triangles, you would be calling two triangles congruent if all six pairs of their corresponding parts were equal. If I had these two triangles ABC and DEF, I will be calling ABC congruent to DEF if AB was same as DE, if angle A was same as angle D, if angle B was same as angle E, BC was same as EF, and angle C was same as angle F, and you can say AC was same as DF. So all these six parts were equal, then you could say that both of the triangles were congruent. And for the case of similar figures were those figures, they were those in which you had same angles, or you can say same shape, but their sizes were different. You can say different sizes. So we had each and everything that we had learned earlier. So these were the things that you guys should remember. So these were the basic differences between congruence and similar figures. Then we had the concept of what? We had the concept of congruency criterion. So what were the criterions? So you guys see we had various criterions. First of those was side criteria, in which we had three of the sides of one triangle equal to three of the sides of the other. So if I had a triangle DEF and another triangle ABC, so DE was same as AB, DF was same as AC, and EF was same as BC, then you could say triangle DEF was congruent to triangle ABC. That was the case of side criteria. Then you had side angle side criteria, in which if you had a pair of triangles such that one side the angle and the other side, that means two sides and angle between them, if those three were equal to the another one, that means two sides and angle between them, such scenarios will be creating side angle side criteria. Then you had the case of angle side angle criteria, which was opposite to side angle side. So in such cases, you had a pair of triangles in which two angles and a common side were congruent to two angles and a common side of the another triangle. In such cases, you said you will be using angle side angle criteria. Then you had angle side criteria, which was similar. You had two angles and a third side equal to two angles and a third side of a different triangle. So in such cases, you said you were using angle side angle criteria. Then we had the concept of why there was no such thing as side angle. You guys already remember. If we have two equal sides and a third angle equal to another triangle in which angle and sides are same, but the thing was this: in such cases, we could have anything. The sides would be different. See, if this was 5, I had already explained that if this was 5 and this was 10, then this could have been 5, this could have been 10, and this could have been equal. But this side would have been, let's say this side was 15, this would have been 10 also. So you guys see, there would have been a difference in the values of the unknown side. Henceforth, you could not say there was such thing as side angle criteria. Similarly, you did not have anything which was angle, because we had considered two equilateral triangles. I had given the example right here. So you guys see, in equilateral triangle, each of the angles was 60, but the dimensions can be different. This could have been 15 centimeter, that could have been 10 centimeter. So guys see, this triangle will be bigger than that one. So the shapes were different, their angles were same. That's why there was no such thing as angle similar congruency criterion, although this is a similarity criterion. So when you get to the class 10, you will be having this similarity version in your triangles chapter there. There you will be understanding why there is such thing as angle similarity criterion. There will be side similarity also, side angle side similarity also. So you will be understanding each and everything in a class 10. Now for the last portion, we had this right angle hypotenuse side. In pair of right angle triangles, if you had hypotenuse equal, one of the sides equal, that means either perpendicular or basis, if any one of these two were equal and right angle obviously equal, then you would say you had used right angle, hypotenuse and side congruency criteria. So this congruency rule is always applicable on right angle triangles, most of the time if hypotenuse is equal. So you have to make sure that if hypotenuse is equal, then you will be using the similarity criterion. Then you had moved towards some theorems in which you had isosceles triangle theorem, which stated that angles opposite to equal sides were equal. This was quite easy to prove. In isosceles triangle, if I had taken a right angle right here, let's say if I had taken an altitude, so these two sides were equal, this side was common, and this was 90 and 90. So you guys see, these two angles will be equal using simplicity, right? Similarly, you had the converse of this theorem, that if the base angles were equal, then the sides opposite to equal angles were equal, which is quite easy to. I had taken this one. This angle was same as that one. This was 90, this was 90, this side was common. So angle side, triangles were congruent. You can say these two sides were congruent too using CPCT. So these were the things that had already been discussed in our earlier sessions. And lastly, we had the concept of inequality in triangles. So I hope you guys already remember that. So inequality of triangles stated that sum of any two sides, if you are talking about a triangle whose dimensions are a, b and c, this stated that sum of any two sides must be greater than the third one. That means a plus b should be greater than c, a plus c should be greater than b, and c plus b should be greater than a. And there we also had learned that angle opposite to greater side is greater and side opposite to greater angle is greater. So these were the things that had been discussed in the earlier session. I'm just going to move forward with this. I hope you are able to recall each and everything, and I hope you are ready to try each and every sum with me. So let's start with the video and very first sum. So we have this sum. In quadrilateral, we have this MCQ. In quadrilateral ABCD, this is a quadrilateral. AC is equal to AD. AC is equal to AD. AB bisects angle A. AB bisects angle A. That means this portion is same as that one. Then the relation between BC and BD. What will be the relation between BC and BD? Now this is exactly from your NCERT. You guys see, this side is same as that one. This side is common. These two angles are equal. So side, triangles are congruent. You can simply state that BC is equal to BD using CPCT. So BC is equal to BD. That will be the answer. Now in next question you have this one. In quadrilateral ABCD, AD is equal to BC. AD is equal to BC. This is actually C. This is the point. This is C. So AD is equal to BC. You have angle DAB, which is complete, and angle CBA, which is this complete. Both of those are equal. If both of these triangles DAB and CBA are congruent, or you can say ABD and BAC are congruent, then you have to find out the relation between ABD. That means this angle and angle BAC. That means this. Now you guys see, if both of the triangles are congruent, then the respective sides will be equal. So angle ABD will be same as angle. See, that is the result here. Now in the third part we have what? Triangle ABC is a right angle in which angle A is 90 and AB is equal to AC. Then values of B and D will be what? You have a right angle triangle in which angle A is 90, AB and BC are equal, AB and AC. This is AB and this is AC. Then you have to find out these two angles. Now guys, remember this is a case of an isosceles right angle triangle. So you guys see, angles opposite to equal sides are equal. So angle B is equal to angle C. If this is x, that is x2. So 90 plus x equals to 180. Angle sum property. 2x equals to 90. X will be what? X will be 45 degrees. So angle B and angle C both will be equal to degrees. I hope you guys are able to understand this one and you don't have any doubt in this, because that will be the answer, which is straightforward, right? So that is the answer. Now let's move forward and see what do we have. In our fifth question, we have this one. The measure of each of the angle of an equilateral triangle. This is pretty easy question. You guys will be answering me this one. So measure of each angle of an equilateral triangle is always 60. We had already proved this one. So this is always 60. If the vertical angles of an isosceles triangle is 40, remember this is 40. We have an isosceles triangle and its vertical angle. That means this angle is 40. What can you say about the remaining two angles? Now you guys see, in isosceles triangles, two sides are equal. Angle opposite to equal sides are equal to. If these two sides are equal, then base angles will be equal. If this is x, that is x2. So x plus 40 equals to 180. Angle sum property. 2x equals to 140. X will be what? Each. So both of the angles will be what? They will be 70 and 70 each. I hope you guys understand this and you don't have any doubt in this. Now in seventh question we have what? If angle A, angle B and angle C of triangles are equal, then the triangle is. Now in a triangle in which all three angles are equal, that is obviously an equilateral triangle. Right? In that case only all three angles are equal. Then we have this one. AC and BD are equal perpendicular. See, AC that is not the figure here. AC and BD are equal perpendiculars to line segment AB. So let's just draw this figure. This is not the figure. This is not the figure here. See, we have AC and BD equal perpendiculars to line segment AB. Let's say this is the line segment AB. AC and BD are equal perpendiculars. So let's say this is AC, this is BD. They are equal perpendiculars. This is 90 and this is 90. If triangle BOC, let's say if I join this one, actually, yeah, I got that. This is a different case. AC and BD are equal perpendiculars. That is not the case. This is wrong here. The figure is this one. The perpendiculars are these. BC and AD. These are the perpendiculars. Then you have to find out the relation between OC and OD. You have to find the relation between these two. So you guys see if the triangles are congruent, BOC and AOD, if these are congruent, then you can easily say that these two sides will be equal, these two sides will be equal, these angles will be equal. So you guys see OD is equal to OC. That is the case. See, there is a mistake here. This is not AC, this is actually BC, and that is not BD, that is actually AD. So I hope you guys have understood the case. So these were the values to your MCQs, your 8 MCQs. So let's move forward and see what do we have. So we have this 9th question. If M is the midpoint of hypotenuse AC of a right angle triangle ABC. This is, let me just draw a right angle triangle. Let's say this is the right angle triangle ABC. Okay. So hypotenuse is AC and obviously angle is at B, and M is the midpoint. This is the midpoint. So now you have to do what? Then BM. This BM will be half of what? See, you have to prove that, see, M is a midpoint of hypotenuse AC, M is midpoint, that means this half is same as that one, and you have to prove that BM will be half of what? This side will be half of which side? Now this is quite easy. I have already explained this question in earlier sessions also. You can just answer me this one, you can just wait for the solution, you can just try this one on your own. So let's see what